आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hello everyone, let's start the question. The question says that define the term degree of dissociation and write an expression that relates the molar conductivity of a weak electrolyte to its degree of dissociation. And here we have the part B. For the cell reaction, NiS2 Ni2 plus in aqueous solution will give Ag plus Ag in aqueous solution AgS. Now here we have to calculate the equilibrium constant at 25 degrees Celsius and how maximum work would be obtained by the operation of this cell. Where here the value is given to us, the E naught of Ni2 plus 2 Ni is equals to minus 0.25 volt and the value of E naught Ag plus 2 Ag is 0.80 volt. Now let's start with our part 1. So in part 1, here we have to define the term degree of dissociation. So the dissociation is a process in which molecules separate or splits into smaller particles such as atoms. And the degree dissociation is the fraction of mole of reactants that underwent dissociation. So from this, here we can say that degree dissociation is the fraction of mole of reactants that underwent dissociation. And here the formula is alpha equals to K upon C. So the degree of dissociation of a weak electrolyte is proportional to the inverse square root of the concentration or the square root of the dilution. The concentration of any one ionic species is given by the root of the product of the dissociation constant and the concentration of the electrolyte. So from this, here we can say that the degree of dissociation of a weak electrolyte is proportional to the inverse square root of the concentration or the square root of the dilution. Now let's see our part B. Now in part B, first of all here write the reaction for this cell here, where at anode the reaction will be take place. At anode the reaction will be take place. Ni will give Ni2 plus 2 electrons. As we know that at anode oxidation will be take place and at cathode reduction will be take place. So from this, at anode this reaction will be happen and at cathode here this Ag plus ions plus electrons will react to give Ag solid. So as here 2 electrons will be produced, so from this here we have to multiply this whole equation by 2. Now from this the cell reaction will become Ni plus 2 Ag plus, it will give Ni2 plus 2 Ag. Now here, as we know that the standard electrode potential of cell is given by E naught of cell is equals to E naught of cathode, where reduction will be take place, minus E naught of anode, where oxidation will be take place. Now from equation will become E naught of Ag per Ag plus per Ag minus E naught of Ni2 plus per Ni plus. Substituting the values in the formula, here we get the value of E naught cell, that is equals to, here the value for E naught cell will become 1.05 volt. Now from this, according to the Nernst equation, here we have the formula for Nernst equation, that is equals to, from Nernst equation, here we get E cell equals to E naught cell minus 0.059 divided by n log of Ni2 plus divided by Ag plus whole square. Now from this, here the value of n is equals to 2. Here the value of n is 2 and the value of E naught cell is equals to 1.05 volt. Now, and the value of Ni plus 2 plus is given to us, that is equals to 0.1 mole, and this is for Ag, it is 1.0 mole. Now substituting these whole values in the formula, here we get, now substituting the values in the formula, here the equation will become E cell 1.05 minus 0.059 divided by 2 log of 0.1 divided by 1 whole square. Now from this, the equation will become 1.05 minus, and solving this whole equation, here we get the value that is equals to 0.0295 volt. Now from this, here we get the value that is equals to 1.0795 volt. According to the question, here we have to find the value of work done. So to find the value of work done, here we have to use the value of E naught cell, and now we have to equate the value of E naught cell with 0.0591 divided by 2 log of Kc. Now here we have to equate this E naught value with this log of Kc. Now from this, here we get the value for log of Kc, that is equals to 1.05 into 2 divided by 0.0591. So after solving this equation, here we get 35.553. Now in next step, here we have to take the antilog of this. Now the value of Kc equals to antilog of 35.553. Now taking the antilog of this, here we get the value that is equals to 3.412 into 10 raised to power 35. Now from this, here we have to find the value of delta G. Now the formula for delta G is equals to minus NF E naught. Now substituting the value in the formula, here we get minus 2 into 96500 into 1.05. Now further solving this equation, here we get the value that is equals to minus 202,650 joules per mole. So this is the answer for this question. Thank you.
क्लास 6 से 12 से लेके नीट IIT जेईई मेंस और एडवांस के लेवल तक 10 मिलियन से ज्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।